Look at all of these scenes. Little snippets of life, ordinary days. At first glance, this is pointless. But when looked into more deeply, you may begin to see all the scientific theories involved in trying to prove how these scenes even exist. This video, for example. The pain of the high five, Newton's third law of motion. What the trees are made of, the cell theory. Actually, what everything is made of, the atomic theory. But there is one underlying theory that is present in every one of these pictures and videos, the main supported theory that shows the beginning of existence itself. The Big Bang Theory. Throughout history, humans have been throwing their best guess, since technically it is impossible to know for sure, at how the universe came to be. Many theories have arisen that claim that the universe didn't even have a beginning, but the most popular theory of today would be the Big Bang Theory. Yes, the Big Bang Theory. When looked up online, the top results are all about the famous television show's upcoming season, news, and of course, fan theories, but those aren't the theories we're looking at. Basically, the Big Bang Theory states that around 14 billion years ago, this entire universe and all of its energy was in a tiny, unbelievably hot and dense particle. Because of all the energy in the particle, it is estimated that the particle was 5.5 billion degrees Celsius. Eventually, this particle stopped containing its energy and began to expand extremely rapidly. And in just a few minutes, an incredible amount of happenings occurred. The first few minutes of the universe are confusing. Quarks, electrons, all the different subatomic particles are everywhere, not connected yet, like how they are today. As the universe expands and its temperature lowers to a cool 1 billion degrees Celsius, those first quarks come together to make protons and neutrons, and later, those protons and neutrons come together to make the nucleus of the two most basic atoms, hydrogen and helium. For many electrons, it still wouldn't have been cool enough to combine with anything. As the universe ages, now 378,000 years old, it finally becomes cool enough for electrons to join the nuclei and make the first atoms. Eventually, those atoms would come together to make stars, planets, new elements, and more. But wait, there's a problem. With all of those loose electrons, wouldn't light scatter against them? That's exactly what it does. In the first 378,000 years of the universe, light wouldn't go through space like it does today. The electrons, moving freely and yet to be connected to protons, would scatter light. Kind of like this, the universe would have been opaque. But when the electrons attached to the nuclei, light began to travel freely for the first time. I know, it blows my mind too. How did scientists come up with this? Find evidence for this? Well, there are two main pieces of evidence that support the Big Bang Theory. Edwin Hubble's discovery that the universe is expanding, and the discovery of cosmic microwave background radiation by Arno Penzias and Robert Wilson. Continuing the research of Vesto Slipher, in 1929, Hubble measured the Doppler shift of many galaxies, discovering that the universe was expanding. The Doppler effect states that when an object moves closer to an observer, from the perspective of the observer, the waves it gives out has shorter wavelengths. When it moves away, the waves it gives out seem to have longer wavelengths, even though the object is sending waves at the same rate throughout. With light waves, the faster the object is moving away, according to the Doppler effect, the more it becomes redshifted. Hubble realized that some galaxies were redshifted, therefore proving that the universe is expanding, since the objects nearer to the edge of the universe's expansion than Earth would be moving faster than Earth. In 1964, Arno Penzias and Robert Wilson picked up a weird hum from their antenna. They first thought it to be caused by pigeons, but it turned out to be much bigger, cosmic microwave background radiation, a kind of echo from the Big Bang. See, when the universe cooled enough, electrons stopped moving freely and therefore stopped scattering light. So cosmic microwave background radiation is the remnants of the radiation of those first photons that moved like the photons of today. And there you have it. Now you can go proudly and honestly tell your friends, I know how the universe began. Thank you.